For those of you that are just joining us, welcome to Introducing the Logstash Grok with Zach Hamilton. Just a few housekeeping items before we start. We'll be taking questions at the end of the webinar. Feel free to ask any in the chat room throughout the presentation. Additionally, we'll be sending out the recording at the end of the week. So without further ado, hi Zach, how's it going?
Hey Gwen, how's it going?
So thank you so much for hosting our webinar today. What do you have for us?
So during today's webinar, I'll be introducing some general concepts around the Logstash Grok, kind of how Grok fits into Logstash, how Logstash fits into ELK, provide some best practices and so on and so forth, as well as examples at the end. So that will be today's session. So without further ado, I'm just going to kick it off here. So introducing myself, my name is Zachary Hamilton. I'm a solution engineer, solution architect, if you will, here at Logz.io. I'll be guiding you through this webinar on the Logstash Grok and all of Logz.io's best practices, why we believe data parsing with Grok is important, and some examples at the end. I want to make sure that everyone feels comfortable using my email address here. That's why I put it up. Feel free to ask any relevant questions about Logstash Grokking, about Logz.io as a company, about centralized log management, or just observability as a whole. I'd be more than happy to present myself as a resource to you. So I will actually put that in the chat right now for simplicity's sake, and give me a moment to do so. I've posted that in the chat. So at any time, feel free to send me an email, and I'd love to get back to you and provide any additional feedback after this session. Awesome. So moving right along, our agenda for today's session, we're going to start with just some introductory concepts of Logstash and how it pertains to ELK, definition of Grok itself, exploration of data parsing and its importance, some best practices that Logz.io has prescribed, and just working with logs in all kinds of different scenarios and companies, and then some specific examples to demonstrate how Grok works in some simple examples. So further ado, I will continue along and get right into the introduction to Logstash. So this session is meant to kind of be able to be consumed by any level of understanding here. So we're going to start at the highest level and just talk about ELK itself. So ELK, or the Elastic Stack, as it's referred to in some contexts, is a open source platform for log analytics, log aggregation. We have these four core parts, as you can see here: Beats, which is the data collection layer; Logstash, which is the transformation layer, or the parsing layer, if you will; Elasticsearch, which is the indexing and storage layer, consider it like a database; and then Kibana, which is the front end, which consumes Elasticsearch and provides visualization and a user interface. During today's session, we're going to be focusing on the Logstash picture here. So we're going to be looking at concepts of how to process the data that you've collected from Beats in order for it to be stored in a format which can then in the future be consumed by Kibana. Logstash as a kind of a transformation layer and a parsing pipeline, if you will, has these three high-level concepts of inputs, filters, and plugins. Inputs can be all kinds of different things, and we'll actually explore that. Filters can be being able to use conditional logic to change specific values, or to split on different values in order to parse your data from different sources effectively. And outputs could be anything from a file to an Elasticsearch instance to a TCP or something like that. Expanding upon that with some specific examples, we'll look exactly at some of the input types. So in Logstash, you can collect from things like Beats, as we've talked about, but you can also collect directly from files. So it's essentially the technology will tail a file and consume that and provide it to the filtering layer. You can read directly from standard out, or you can accept on some kind of TCP socket, and many, many more. This is just a shortened list of some popular ones we see our customers using. The filtering layer, once the inputs have been accepted, allows you to do things like aggregate on specific values. So if you have a value that you want to aggregate across a specific period of time, you can. You can do splits, so if you need data of a specific type to be kind of forked based on two different criterias for different outputs potentially, you can do that. Then another popular use is throttling. If you want to be able to manage the rate at which logs are being processed by Logstash, you can absolutely use throttling in the filter layer so that you don't kind of put too much performance overhead on the machine that is hosting Logstash. Finally, obviously, what we will focus on today is Groks, which is the kind of the transformation piece of the filtering layer. It's the ability to create, take unstructured data and create structured data out of it in JSON or some other type of format. And obviously, once the inputs have been consumed, filtered, parsed, and done whatever at the filtering layer, you need to provide an output so that it can be stored somewhere or it can go to the next phase of the overall process. Very often, this is going to be Elasticsearch, as Logstash is a key component of the ELK stack, but it can also be something like a file, a TCP socket, a queuing system like Kafka, or many, many other things. All this information can be found easily searchable if you type in Logstash input, Logstash filters, Logstash outputs on Elastic's website, and you'll get a very, very long and clear list of all of these available filters, inputs, and outputs. Moving, kind of drilling in further, we've started at the perspective of the ELK stack and an open source logging solution as a whole, and we've drilled into a subcomponent of that at Logstash and then divided that into three categories, and then specifically took one component of one of those categories. So that's kind of the drill down if we've gotten down into Grok. So in the filtering layer, Grok is used to parse unstructured data into something structured like JSON. Essentially what Grok is, you can think of it very similarly to something like regular expressions, which many people are familiar with. However, the differentiation here is that Grok is essentially a library of terms that wrap regular expressions and kind of anonymize regular expression patterns into simple consumable things. You can see here that we have this example for int and then all of the special characters that are the regular expression. Int in this case is the Grok phrase, and this set of special characters is the regular expression that it is basically wrapping. And so anytime you reference int, that is exactly what you're applying in parsing. So a little bit about the Grok syntax. The Grok syntax is of basically you choose one or many of the following matchings. In terms of special characters, a Grok match will start with a % followed by a curly bracket. There will then be a Grok phrase, a semantic, and followed by the closing curly bracket. The Grok phrase is exactly like int in the previous example, and the semantic represents the field that you want the value match of the Grok to be mapped to. And I'll provide a specific example of that. So in the example above, you see that semantic M is the field mapped to the Grok pattern Grok plus N. In this specific example, which we'll actually demonstrate live later on in the examples part of the demonstration, we have here a simple, just it's not a real log message, but it looks very much like one. We have a timestamp, a log level, and then a message that has been printed after it. In order to create a Grok that would extract this data, it would be something like this, where you can see that it's consistent, that there's always % and then wrapping curly brackets, but then there's a Grok phrase, in this case timestamp, word, or greedy data, followed by a semantic like time, level, or message. When this matches something on a log line, the value of whatever the timestamp Grok matches will then be mapped directly to the time field, and so on and so forth with level, and so on and so forth with message. Now, greedy data, because that looks a little bit funky, and just a little bit more explanation, that is a popular Grok that basically it will just match anything to the end of the line, or a return carriage, or a new line character. So that will grab the rest of that message, and we'll show some examples of that as we go on. So the next part of this exploration is, why do this at all? So we've talked about logging and log analytics at a macro level, and we've looked at a specific transformation layer and how you can do things along the processing pipeline there, and then a specific way that we can structure or parse our data. But it's really important to explore, why do that at all? So as you can see here, some of the things we see most valuable out of data parsing is the ability to effectively query for values, rather than have to write a complex regular expression in order to match a specific pattern in an unstructured log message. Parsing it into fields allows you to match on the specific field values, and you can be much more granular with your searching. This also allows you the ability to create visualizations and dashboards. Unstructured data does not have the ability to make meaningful visualizations. Maybe you could do a count of total messages coming from a source, but you definitely can't extract something like a response code specifically and get a count of its differentiated values. Next is the ability to filter for or filter out specific fields, and I just use the example of response codes, so something like access logs. Fairly often, response codes 200 represent a lot of noise in access code, access logs on machines. The ability to extract that, because it's parsed out, allows you to remove that noise and focus on things like 400 or client-side errors, or 500 server-side errors that you want to be able to look into in order to troubleshoot problems. And finally, the ability to actually alert on specific events. Since we're parsing this data into a very specific structure, we can actually take specific events in that structure and look for patterns in order to create alerts. If I have a tolerance of, in any 30 minutes, 15 error 404s represent something that my system can't tolerate and we need to troubleshoot immediately, I can alert on that specific instance if I've parsed my data. Finally, those things are obviously values that you have access to by parsing your data, but what does that provide to you? What are those specifically kind of amalgamate into in order to provide value to a business? And really, that is just context and methods for making this data actionable, and doing reporting from the log data. We wouldn't be able to create very meaningful reports for executives if we didn't have the ability to create visualizations. I would suggest that most executives probably aren't going to look at a long list of log messages and extract value in the snap of a finger, but if you show them specific charts that represent the same data, it's much more actionable and you can make decisions much more quickly. So the next thing we have here is our best practices. So these are things that Logz.io has seen as potentially valuable from working with many customers to make their log data most clean, most uniform, and standardized. So the first one we always prescribe is standardization. So choosing the right logging framework and creating standard field names, and I'll give examples after this. For instance, you could, in a Java-based application that's on a Apache Tomcat web server, you could use the Apache Commons logging framework, or you could also use Log4j. If you have multiple web servers using different specific frameworks, your logging convention from the same technologies is disparate and it's hard to troubleshoot issues that might be distributed across them. Next, adding context or a storyline with plenty of peripheral information is important. And what I mean by this is logging, error 404. If you just had a timestamp that said, timestamp level and error 404, received, that wouldn't tell you very much. What's the verb from the request? What's the client IP? What's the request path it was trying to connect to? So on and so forth. Adding a storyline in the specific log message helps you connect this to other features of the data using that peripheral information so that you can see if it potentially permeates to other technologies and how widespread the issue might be. Next is using unique identifiers. And the concept of this plays very, very closely into something like tracing. If I have a upstream event like maybe it's a transaction that was aborted, and that's the specific example I'll give you in a few minutes here. A transaction was aborted, and I have a unique identifier for that workflow. I can see downstream that this caused some kind of database failure or something like that. So we can actually connect the events together because we can look and filter specifically for the unique identifier, and we can collect all of the events that are coming into a specific transaction and see how they affect each other. Finally, formatting is very important. Our best practice and what we always would say to our customers in a perfect scenario is logging in something like JSON or key value pairs is very, very significant. These are both best practices. If we were to prioritize them, we would say that JSON is specifically a little bit greater, but key value pairs is also still a great practice, and I'll show you two examples of those afterwards and explain it in a little bit of depth. So taking these best practices that we've just given and kind of adding some color or a little bit extra explanation to them so they make a little bit more sense is these specific examples. So in standardization, you can see here that we have basically the log level, right? We have the log level of error. And in this specific instance, we have two field names that represent the same value. So we have level equals error, and we have log level equals error. Fundamentally, we're talking about the same thing in this context. However, if we were to try and search for all logs where level equals error, we're going to have to write two specific search terms in order to capture this from the two sources. We will have to say where level equals error and where log level equals error, rather than just having a standardized format of level and being able to say where level equals error. So standardization across different names, things like source IP address or client IP address or just IP address. It's great to try and define a standardized format or a standardized naming convention across systems for correlation. Next, as you can see here, we have add context. You can see the top message we have here, just a timestamp and login failed. This is versus to a scenario where we added in a little extra context to that message. We have the timestamp, then we have user ID equals 23, we have action equals login, and we have status equals failure. We've captured the same information as the first log line, but we've added a little bit more color into the context. You can see here that now we have the understanding of at least something that was completely inaccessible of which user had a login failure. And now that we've mapped the specific action and the status in a key value pair format, we can do things like pin on user ID equals 23 and then see all actions. So logins, logouts, where the status is failure, where the status is success. We could then go further and pin on, I want to see user ID 23, where the action equals only login actions, and then see a distribution of all the statuses and see, I want to see how many account of the failures, I want to see account of the successes. And then you could use this information to come full circle with the example previous about alerting. I could say where any given user has an action equals login, where the status equals failure, and the count over 15 minutes is greater than 5, send us alert because this is someone causing a problem and maybe someone's trying to break into our system. Next, moving forward in formatting, you can see here that both of these messages in both JSON and key value pairs provides information to any user who could come in here. And the importance of the formatting and using one of these specific conventions and why it can provide a lot of value is specifically because if I wrote the code as a developer, and I write the code that does all the logging, and then someone in a DevOps or an operations team who experiences a problem and needs to remedy it, comes in and looks at all the messages, and we have something like over here where there's no real color and there's no specific key value pairs, I might not necessarily understand what's being represented in the data. We always prescribe JSON as if it's the best case scenario, we would say use JSON versus key value pairs, and the simple reason for that is that JSON is basically the format in which data is stored in Elasticsearch in terms of ELK stacks. So if you're working with an ELK stack and Logstash specifically, logging directly into JSON makes the transformation you have to do in Logstash much more lightweight, and there's a lot less overhead. But something like key value pairs is still very, very effective because I know without a question of a doubt that this field is level, that this field is message, and I can see that exactly what the value is mapped to it. Moving forward for unique identifiers, you can see here that I have two examples I have. First, I have a servlet called store checkout with a message, and that message is error committing a transaction, and then a specific unique transaction ID. Somewhere else in the logs that we are collecting, we have 5 minutes earlier where there's a database called new orders, and it sent a message called unexpected error, and the action it logged was a shutdown action, and it also contained that same unique transaction ID. If we start seeing all kinds of error committing transactions from our store servlet, our checkout servlet, that could mean maybe our business makes money on the internet. Maybe these are customers actually trying to submit orders to us and actually make money for our business. We want to be able to, as quickly as possible, figure out exactly what is the error in our system that's causing these errors for committing transactions. With the use of a unique identifier in this case, we could pin specifically on the unique transaction ID and be able to see that, looking at the timestamp about 5 minutes before that, this DB for new orders basically is shut down due to an unexpected error, and we need to task people to go figure out why the database shut down and get it up and running as quickly as possible so that we can start accepting these transactions. This is the kind of correlation that you can do with unique identifiers that can help you reduce the time it takes to troubleshoot. So now what I'll do is I want to give some demonstrations specifically of how you can write some of these Groks. I'm going to use 3 specific ones in order to do that. Give me a moment while I actually pull up my other window here. All right, so what we have here and what I've just pulled up, this is a Grok Debugger. As you can see, it's just a Heroku app. This is not a Logz.io technology. This is just a free tool that's available on the internet. I can post the link to this in the chat after the session so that everyone can have it available to them. But it's also available online if you just Google search Grok Debugger. So if you remember from earlier in the session, we gave a specific example when talking about the Grok Syntax. We used this exact example for how we could parse some data. So I'm going to write a Grok that would parse this in order to exemplify how we would do this in at least a very simple way. So I happen to know all of the Grok patterns ahead of time now in order to apply and basically understand exactly which Grok phrases will match these specific terms. But if you needed to look up Grok phrases, there's Grok references online, and actually let me pull that up for you and show you what I'm talking about. This is how you can look into what Groks are going to match on what things and so on and so forth. So as you can see here, I just pulled this up. It's on Elastic's documentation for Logstash. and some examples of available Grok patterns. This is a great reference to have when you're trying to write Groks, because you can specifically look and you can test the Grok phrases followed by the regular expressions that they match in order to test and over time use the Grok Debugger to figure out how to parse the messages that you've added as examples. I'll make this available in the chat as well because it's great to use as reference. Now, coming back to our Grok Debugger, I know exactly what of those phrases in the reference are going to be applied, so I'm just going to use them. So first, we have a timestamp. I happen to know that this is an HTTP date timestamp, and that's the format. So I can type the Grok phrase HTTP date. I want to map this to a field called time, so that's our semantic. And then in order to close this out with our Grok syntax, I can do the curly brackets. You can see in real time that it's updated to demonstrate exactly what's going on here. You can see we've mapped that entire basically timestamp that we see up here in the example message we provided to the field time. And you also might notice that there's some subfields. And this is because HTTP date itself is a combination of multiple sub-Groks that are meant to extract the information and to provide a little bit more enrichment. Next, I'm going to grab the log level, and I'll show two examples of sometimes multiple Grok phrases will be able to capture this. So I can write here, I could write word, which basically maps on any word, so alphanumeric characters before and after space, and delimiting against break characters. And I can call this level. And you can see here that we've updated it, and we can see that debug was captured by level. There's also a Grok phrase that is specifically for log levels that you can use called log level. And it will extract debug just the same. Now the differences in these are simply that a word will capture any alphanumeric characters between break characters, whereas log level will specifically look for the terms of debug, high, medium, low, info, whatever. So only log level terms, not specific. So this is a little bit more robust, or this is a little bit more specific, whereas word is a little bit more robust. And if you had some kind of your own log level that you've defined, you would need to use word because the log level Grok wouldn't capture it. Finally, we'll use greedy data to just grab everything to the end of the line. So I'll type in greedy data, and then I'll just call this the message. And you can see here that if I scroll down to look at that, we've been able to extract this into the message field. And this is a generic log message example, and we've extracted that. This is obviously a very simple Grok that we've written. So now I'll provide an example of something a little bit more complicated. Give me a moment while I just type it into the interface here. All right, just another moment while I type it. Okay. And believe it or not, I wrote that super fast. I did all of that. I furiously typed away all those special characters from scratch. No copy pasting was used here. I copy pasted this from another document that I had, my clipboard, just because, as you can imagine, it would have been a little tedious if I went through and explained every single thing that was going on here in this Grok that I did in order to extract data from this Apache access log. So what we have up here is just a regular Apache access log that I was able to extract from one of my environments that I use for demo here at Logz.io. Now this is a Grok phrase that will actually capture it. So you can see here I'm getting the IP or host. Believe it or not, I'm actually matching the user identity and user authentication against these fields, and then something like the timestamp. The things that I want to demonstrate out of this are very high level and not specific to Grok and its syntax. But notice here that I have things like I have a backslash, I have this pattern here. And I want to provide a little bit of color and explanation of what that represents. So hopefully I can be as clear as possible about this. Grok Phrases basically match against regular expressions, correct? We all understand that. But around Grok Phrases that you're using, you can still use the regular expression syntax. So you can see here that this is a Grok pattern. We've got the same simple syntax that we've been exploring throughout this call, but then we can also notice that we have the open parentheses, question mark, and the semicolon to do an uncaptured group using regular expression. Likewise, we needed to use the escape character of a backslash in order to escape the bracket. We wanted to capture this literal bracket from our timestamp here, but as many of you may or may not be aware, brackets are a reserved character in regular expressions. So what I'm trying to demonstrate with this and not go through every single feature of this Grok is that regular expressions can still be used in the syntax of surrounding Groks, even though Groks themselves are wrapping around regular expressions. A little bit of a confusing explanation, but you can use all of the regular expression, different formatting and types in order to provide extra value. So this is a Grok that will actually parse an Apache access log, as you can see here, and we've got our client IP, our host name, and if we scroll down slowly, we can actually see all of the different fields that were extracted, like the request path, so we can see what they were connecting to, the HTTP version, the response code, and the number of bytes that came out of it. Now, for my last example, I want to provide another exploration and using the same log, but showing how you can simplify and showing how Groks are very agile. Cool. Right. So now I've deleted that pattern, and you can see we're not capturing any fields. Groks themselves can be wrapped by other Groks, and I want to show the power of this because we can hopefully agree that that Grok pattern I just demonstrated was a little bit more complex because it had a lot more going on because, well, the log message is a lot more complex. We can summarize that entire Grok expression into a single Grok to make this so much easier. I could type in the Grok common Apache log and call that Apache. And that will capture absolutely everything we just captured, the same exact way. Fundamentally, the common Apache log Grok is actually the summation of all of those subparts that we just saw there. And you can see this if you look at the Grok reference, and this happens all through it. So Groks are very powerful because now we took a very complex phrase and we were able to just basically create it into a simple phrase here where it's very easy to understand, and now I can reuse this wherever. So those are going to be our examples. I'm going to transition back to our PowerPoint here just so we can come full circle and kind of summarize what we've hopefully learned today. So looking at for some key takeaways, so to kind of go through what we've explored today, we talked about an open source logging stack called ELK, where Logstash fits into that, specifically its subcomponents and where Grok fits into those subcomponents, how to use Grok, what's the syntax, why do you even use Grok, and what values could that even provide. Then we looked at some best practices and some things to keep in mind when actually executing Grok phrases themselves. So some of the key takeaways that I would prescribe are the fact that standardized logging helps you connect issues between all kinds of distributed technologies. Environments in the businesses I've been talking to are always getting more complex as people adopt things like Kubernetes or microservices, so on and so forth, things like IoT. Logging just becomes more thinly spread and less all in one place, and collecting them and then making actionable insight out of it becomes more and more difficult and more important for troubleshooting. Meticulous parsing can help you actually get access to that insight that you're looking for across all of your distributed systems. So once you've gone through the task of collecting all your data, it's very important not just to collect it, to make it actually searchable, filterable, and presentable and actionable. If we can just put it all in one giant pile, there comes the whole concept or the analogy of finding the needle in a haystack. If we just have a giant pile of logs, it's still difficult to troubleshoot. So parsing can help solve problems in that. Finally, mature logging helps organization responds to issues more quickly, reduce downtime, create even potentially auto remediations for problem, and give back to the bottom line. If an engineering team can troubleshoot a problem that normally takes a week in a single day, then they have 4 days given back in their schedule where they could provide more value to the organization or save the company money. So how Logz.io fits into all of this? We've been talking about open source technologies and things that are completely agnostic to Logz.io for pretty much the entire duration of this session today. Things like parsing and writing Groks is something that Logz.io provides as a service as a company. So customers who are trying to collect all their data, like I've just discussed, they collect it all by just shipping it to Logz.io. Then taking that giant pile of logs, Logz.io provides that as a service in parsing, and we will automatically parse all of your data for you. Rather than have to manage your own technology stack, Logz.io provides this as basically a fully managed service, and you get just an interface to create visualizations and to search your data without having to worry about setting up. We talked about alerting and how that can be valuable. Logz.io has an entire alerting engine that can provide messages about things going on in your data to all kinds of various sources, like your communication platform, like Slack, your ticketing platform, like Zendesk, or maybe your DevOps tool like VictorOps or something like that. Next, we provide processing of your data with machine learning models in order to tag important events that can be from configuration, security, or performance. So when you're not necessarily haven't even realized that you need to go look for the needle in the haystack, Logz.io is automatically using machine learning to always look through that haystack in order to find any needles that we've seen other customers find a lot of value out of. And finally, all of this is provided as a completely managed SaaS solution. So you don't have to worry about the administration of any of these technologies. You're given an interface in order to work with your data, and the only responsibility of a customer of Logz.io is just sending logs to us so that we can handle the rest. Now, kind of making some resources available to you. On our left here, we see we have our own blog, and this can provide a lot of insight into how to work with Logz.io, but not just Logz.io specific. This is also a lot of things around just general market concepts, like how to set up your own open source ELK stack or do it DIY. You can find out how to use all kinds of open source logging technologies to provide logging to your business in our blog. We also have a complete guide on how to do ELK, and that kind of ties into the blog, as well as a free trial that you could test it out from a Logz.io perspective. Finally, the docs and the academy represent two sources where you can get information if you're the type of learner who likes to consume videos in order to understand how to create a visualization or how to do this or that. The academy is a great resource, as well as the docs if you want the technical documentation, you want to be able to copy paste real code that you can use. You can do that as well. And then finally, you also have another resource in me as a solution engineer here at Logz.io. So my email address is in the chat. It's up here as well. So if you have any questions about anything that I've explored today, any general concepts, you can feel free to send me an email, and I'd be more than happy to respond. So moving forward, we'd like to open it up for some questions. We're going to pause here and give people kind of a chance. So I'll probably say 5 minutes. So at 7 past the hour. We'll give 5 minutes to ask any questions. If you don't have any questions and this is your time to drop off, thank you for coming today. And we appreciate the time in order to teach you some things about Logstash Grok. But if you do have any questions, feel free to put them in the chat now. All right, it's been about 3 minutes. I'm going to give it another, 2 minutes here, just in case you want to post any questions in the chat, and then we can address some of them.
Hello all. So we're back here. We've got a few really good questions. So we're going to kick it off with Zach. If we have fields in our logs that we want to use to create a new value from, is this something we can do with Logstash or with Grok?
That's a good question. I've actually run into this case a couple times, and the simplest example of doing something like this, an operation of this type, is I was working with a customer who wanted to take something like request and response processing times, and it was valuable to them to see the total time that it would take to do processing of anything on their web servers. So with Grok and with Logstash, you absolutely can take those two values and you can add them together in a sum in order to create a new value or a new field called total time that allows you to see the total time rather than doing a sum on the fly or something like that. This is also something that Logz.io does very, very frequently, and we provide as part of that parsing as a service.
Interesting. Okay, so the next question, do I have to make one Grok for all my data, or can I have multiple Logstash Groks in the same configuration?
If I understand the question correctly, the question is that is there one really complicated Logstash or like one Grok pattern that has to be able to match against all log types, or can I have specific Groks for specific types? If that's the question, then the answer is no, you don't have to have one giant complex Grok. Since you can use like a split in the filtering portion of Logstash, you could split against a tag that you'd applied when the input is ingested. And then after that split, you could provide a Grok as part of that split in one case and then another Grok in the other case. So you would be able to provide Groks specifically to the data type that you're, or the log type that you're trying to parse.
Okay, thanks for that. Last question. Regex is rarely done right the first time around. How frequently is the standard patterns library being scanned for human error?
That's a great question. So if by pattern library you mean like the Grok reference, or how frequently are new Groks that are added to the library of Groks checked for any potential issues, my best answer would be that, to be completely honest, I'm not sure. Grok is completely maintained by Elastic. It's an open source tool, so it's not something that is the responsibility of Logz.io. We can't actually influence that even if we tried. My best practice is I use a website called Regex 101, which makes it very simple to copy regular expressions in there, and it will automatically flag any like syntax issue that is presented in there. It's color coordinated and it's very user friendly. That's usually how I check for errors when I'm writing Groks, but in terms of the frequency of these things being checked and updated, from Elastic's perspective, I can only speculate.
Okay, great. Thank you all for those questions. We're going to wrap it up now. Thank you, Zach, so much for hosting this webinar and putting it together. Just a reminder, we will be sending out the recording by the end of the week. Everybody, I hope you have a great day.
Thanks, Gwen. Thanks, everyone, as well. Just one final time, my email is in the chat. Feel free to reach out with any questions. I'd be more than happy to explore how you can use Logz.io or how that could potentially provide value to your business.